Hello everyone. So today we'll take a look on vellum grains. So this is what we'll achieve. So I did this render at the night, and this you can see these clumps. I'll tell you how to make these clumps. Okay, I'll hold it. Yep. So you can see this is a clump. This is a clump. I can give them another color also. Okay, and these are the small clumps which then broke. So we'll see from the basics what are the nodes. I'll create everything manually with the collider and everything. So this is how we will do. So we'll start with the empty scene, and I'll set my project to my tutorial. To and okay, so I'll save this scene as a uh, tutorial underscore version 01. Okay, so we'll start with the rubber toy or any model with toy, whatever we want. So we'll take rubber toy. Yeah, we got him. Okay, so then we'll take a transform node, and move it up. Sorry, move it up, and I'll rotate it a bit in different way. Yeah, so we have our model. So for creating vellum, we need first node. This is vellum configure grain. This fourth one, and we connect that one. So as you can see, I clicked but nothing happened. So what we have to do, we have to click here, create points from volume. Just click on this one, and it converted. So what is this? These are the points. So and which on which we have a sprite material. So this is a material. This is like same Maya sprites. Wherever your camera, they are facing that 2D only. So now if I'll remove this, you can see they are only points, and we have a grain size. If I'll decrease this size, so you can see we have more. I'll again do this. Yeah, so as you can see, now we have more, and if I'll do 0.01, we have more and more, which we will use later. For now we'll use 0.075 maybe. Yeah, this much is enough for now. So we have vellum constraint after vellum grain. Now we need a constraint. Okay, this vellum constraint. Yeah, and then see this. Okay, I'll show you. So this is for geo, this output is for geometry output, this is for constraint, and this is for collision. So I have only geometry now. I don't have any constraint. Even I'm not creating constraint in this one, but we can create constraint with this. So same constant, same logic, that we can use connect adjacent pieces, and you can create. So now what we have this. So we'll take this output and create a null, and we'll name it geo, and one more. This one is constant, which has nothing, but we need these both for simulation. So we have this geo and this constant, and later we'll do a lot of things here, I'll tell you. So for now it is okay. So now I'll create a dopnet. Okay, so first of all, what we need a vellum object, uh, and we have to call these material this object and constant. So see here, this is initial geometry and initial constraint. So what we have to do, we have to just hover to our geo, and here we want our constraint. We have both. If you will click, you can see, and hide other objects, so you can see only this. Yeah, so you have this. And after this, we need a vellum solver for solving this. Yeah, and then we need a gravity force and output. So we got this. If I'll play now, you can see it is falling, but there is no ground, so I'll create a ground plane here, and I'll merge. And always remember, first output geometry, second output gravity, then this one. So if I'll play now, you can see it fell down and it blasted. It doesn't look like a sand or something. If I creating snow or sand, it doesn't look like that now. It look like particle are falling. Okay, so I'll lay out it. Okay, so we have this. So okay, I'll increase a bit of I'll go for 0.05. Okay, again, so I'm in .NET. Again, I'll play it. You can see same effect. So first of all, what you have to do, you have to go to ground plane or whatever if you are using a collider. So go to physical, bounce 0, forward 0, and I'll make friction 10. So you will get a little bit change, not a lot. Yeah, see, little bit change in the simulation. So then we have this Vellum solver. In Vellum object we don't have that much settings. We have like thickness, you can see what is the thickness, even you can change it also, see, but it is okay enough. And failed self collisions, when you will play this one, then you can see those things. And this is for constraint. So now what we will do, so okay, I'll show you first. In Vellum solver, in Vellum solver, yeah, so in Vellum solver we have these settings. So I'll tell you what is this. So first, time scale, same for timing. Velocity damping, if you'll increase this value, see what will happen. If I'll make it 0.5, so it will damp our velocity, see. Okay, so I am making it 0. I don't need this one. If you'll make it 1, it is like ultra slow. It is multiplying with the your external whatever this velocity, it is multiplying with that, and it will create damp effect. So it is damping. I'll make it 0. Sub steps, it is the like most important thing in Vellum grains. So what is this? If I'll see, I didn't change anything. If I'll play, you can see same effect. And just if I'll make it 10, you can see that effect change a bit. You can see now they are not jumping a lot in center. They're going here and there, that is okay, but they are not jumping. Before they were jumping. This one is constant iteration, how much time it will solve the constraint. And this is smoothing iteration. So if there is something like failed, our process is failed to iterate the constraint, then again it will iterate for 10 times. So if I'll increase this value, then we have to increase this value also. So it is also very useful. Then we have collision. So we have collision passes, it will calculate 10 times. Then again same post collision passes is like same like this smoothing iteration. If collision will fail, then it will do the process. Then we have a static threshold. So if I'll increase this value, you can see. So one more thing you can do, you can click here question mark if any tab, so you can see this node, and you can read everything about that node. You have all the settings. So like this static threshold, what is static? A threshold at which to apply full friction. So this is a threshold. When the value will exceed, then friction solver will apply full friction on this, and this is the scale for that friction. And it is external enable, same, we can go and check what is that. Here you can see external enable. It is also a scale factor of the amount of friction effect to apply for collision with external geometry. If you have any external geometry for collision, then then how much friction amount, it is like scaling, it is not the amount. It whatever, if you will make 0.1, it will multiply with the value. And this is self enable, it is for self collision. If we'll make it 0.1, say same thing, the scale factor on the amount of friction effect to apply for collision with self geometry. If whatever, if they are doing self collisions, so whatever that iteration, so if I'll make it less, so it will it is like a scaling factor, how much friction they want. And so after that I'll show you what is useful for now. This thing, grain collision. So in grain collision we have this attraction weight. So if I'll make it 1 and play, you can see something cool. Yeah. So now we have a attraction. See, there is a search radius, a search scale. So it is 2.5 and maximum neighbor from one particle, you can say one grain particle. It will find 20 neighbors, and this is the global weight 0.5. And repulsion weight, repulsion. Okay. So attraction weight, what it is doing? It is attracting towards itself. Okay. So now what we want? We want like clumps. We don't want this attraction on complete. Maybe same thing you can do. I'll create for this one. You can create for repulsion also. For other things also you can create. So I'll show you how I can do this, that do that thing. So one second, what happened? Okay. So I'll select this one. I'll go down. So from here, so we have these. I'll even decrease the size for now. So yeah, we can see. So now if I'll create a attribute warp which will run on the points, because these are points, and I'll go inside it, so you can see same. So what we want, we need a noise. So we'll take a anti-alias noise, and I'll plug this point to position and this noise to color. So we have this. So I'll change the noise a bit. I'll make it yeah, this is okay, 6x6. So we have a lot of noise. So black and white. So okay, first I'll show you, and I'll export this noise with bind export as a attraction weight. I'm not creating a new parameter. This is inbuilt parameter. I'll show you in this one. If you'll go to solver and middle click, okay, yeah, middle click, you can see attraction weight. We have attraction weight. So I will just override this one with my values. Okay, so we got this one, and I'll show you. I'll take color, and you can check with this one, run with the attribute, and we can put attraction weight, and you can change color for better preview, green and blue. Okay, attraction weight, okay, maybe I wrote it attraction weight, it is right now, attraction weight, correct. Okay, sorry, I didn't check this one. Okay, so okay, I'll take some better color. You can see the green is more and this red is less, as you can see. And yeah, so now you see first what will happen. So we have attraction weight on here. We have to put value 1. Automatically it will calculate where it is 1. It is, so you can see even here. I'll show you one more thing. So in color you can check here attraction weight. So we have a value from minus 0.4 to 0.4, and we don't want this value to be negative, otherwise they will do repulsive. So what I will do, I'll put a fit, and you can see with the fit it is going from 0 to 0.4. You can check in this one. Okay, so yeah, for now make it like this, because I have to change some things later, which I'll show you. So we have this. Okay, I'll disable the color. Yeah, so, and now I'll play. See, okay, one sec, maybe I made this value, it will take time, so I'll decrease this to 0.35. Yeah, I don't want to give a lot of time for this sim. It will take extra time, so see what will happen. Oh, one sec. As you can see, it fell down, and you can see these whites are a bit together, but these blacks are going here and there. Check. Even yeah, see, these whites are like clumps and these are going. So what is the issue? Just where is this swap? Yeah. So I'll go and increase the value to 10. Now see what will happen. The more white, the more attraction weight. Now you can see this clump. You can see this pure clump. Okay. Yeah. So this is how we create clumps. And one more thing, if you think like this black is like they're sliding a lot, and so what you can do, you can go there in attribute warp, and this destination minimum, what it will do, it will change this black from black to a bit grayish. Okay, 1 second. Okay, this value I multiplied now. Okay, it is calculating. I hope I'll make it 1 again. Go. Why it isn't working? Okay, there's some issue. 1 sec. Oh. Okay. It is happening, but we can't see this. I didn't check this one. And see if I'll put in CD. Yeah, sorry. So if I'll move this one, it will again become white. I'll change it to 10 again, maybe 5. Yeah, and what I will do, from this black I'll make it a bit of grayish, not a lot, but yeah, 0.1 is enough. So what it will do, they will not slide a lot, they will also try to bind itself with 0.1 value of attraction weight. You can get like that. So see, these blacks also are not sliding a lot, some are going, that is okay. And see these clumps. Okay, so we got this one. And now what is about collider? So we have collider. So first I'll create a tube or something. I'll create a cube. Okay, take a cube. Okay, sorry, box, not Maya. Yeah, so I'll create a box, I'll show, and what I'll do, I'll make it up, I'll size it down from top also, and I'll make it longer. Move it this side. Yep. So we got this one. What we have to do, we have 3 things to do, means we have 3 types. So what first we can do, we can select this one and we can go Vellum and create, select this one, surface collider, it will automatically create for you. And otherwise you can go to static object and select this one, done. But I'll make it by myself. So what I'll do, I'll create a static object here, create a merge node, and see this knife thing. One of my friend also asked me how you did this. So this is very easy. You have to just press Y, automatically this will, and then left click and cut. So easy. And yeah, and now check. Okay, sorry. I have to have a one there. I have to go and check this box, accept, and I'll try to play. We'll check and hide other object. Is it colliding? Yeah, it is colliding. So you can directly click here and create that, or maybe you can create by yourself. You can see how they look like now. Yeah, they look better than my one, whatever I created. So one more thing I'll show you. So now for caching purpose, how you cache, that also I'll tell you. If you are done with the simulation, you have to just create a geonode and you have to create a DOP import node, and here dop network, you can go like this, but I prefer dot dot slash dot net. Yeah, and in object mask I'll put vellum, and this, you got this. So what is vellum? It is searching for the object with the name vellum. I know I created vellum, and this fetch geometry from dop you have to do if you are working on RBD and you want for UV and something, then you use this thing, fetch unpack geometry from dop network, and stamp point, lot other things. So we got this one, and what we can do, we can color them. See, I need a color, so this point and this one we can do bounding box. See, we have a different color, but I'll do attraction weight again. I'll use that one. Yeah, and you can see I can make this a bit grayish. You can see these value. You can make this one darker, or maybe if you want to make it more visible, you can make like this. Yeah, dry sand and that thing. Okay, yeah, it look nice. And we can go, and what we can do, we have this one. So if you don't want to go again and again inside this and change this, so what you can do, you can create a null over here. Yeah, and I'll change the shape. Z, you can change the shape, and C to change the color, and name is control. And what you can do, you can click here and go for your edit parameter interface. So easy, and you can take a folder, put in the root, got the folder, and you can name control. Oh, sorry, control. Yep, and what you can do, you can take a float and put here, and name it. What is this? Size. Copy, paste, home, size, and accept it. So you can see we have this one control with the size. So what you can do, 0.035, copy this one and go inside this, and here right click, paste relative reference. Yeah, so now you don't have to go again and again inside, and close these all. If this is okay, and you can go and make it like 0.02 and go to first frame. You can see it change. If you'll go for 0.01, you can see it will change. Yeah, but it will take a lot of time if I'll do now. So on this frame only, I'll tell you how I did shading for this. I use same color. You can use this same color for rendering. So what I'll do, I'll create a camera, new camera with the same view. Yeah, and I'll go for out, and I'll create a mantra node. So in material, you can go and take principal shader, and in OBJ we have this Geo1. In this you can go and apply that material. Yeah, so why color doesn't change? So easy. You can go surface and you can see use point color. Okay, so what we did, we have given a color to the point. Okay, which is here in Geo1. I gave this a color on point, so we have this color. So whatever we will do on this one, it will multiply with the color. If I'll make it 1 1 1, you can see it is multiplying. So always make 1 1 1, otherwise your color will be dull. And same, reflectivity less, roughness more, and no transparency, scattering. Okay, for now basic thing. And if I'll create a light setup, and or maybe I'll create directly a skylight, so we'll get better lighting. Yeah, and I'll go to render view. Shit, no, escape. Okay, so I'll create a grid also. This is the same setup whatever I did for whatever I showed you in starting. Same thing. Yeah, so you can see if I'll render it, how it looks like. Okay, I have to select that cam. So See, you can make it more smaller depend on your PC. You can see colors are also coming. Yeah, so we have I have this one. I'll show you. I'll go to file node. I'll show you. I did one caching before. Yeah, this one, and I'll connect this color. See, and you can see this is animated, but that attraction value I made very less. So in this one, that color, the amplitude value, so that's why we have less clumps, but in our new one we have a lot of clumps. So you can see in render how it looked like. Render it, and that is on point 1 point 0 1, sorry, value. So as you can see how it looked like. And see that color inherited, and you can color by yourself with, that is artistic decision. And for these I increase this one also. In out I always increase this pixel sample also, because they are small particles, so it needs a lot more to render this clean. Yep, so I'm done for this one, and I'll make more tutorial. This is the one I want to show just what is Vellum, how you can import, how you can create first source and everything. You can even use this as a source also if you'll go in .NET. Okay, yeah, so I used here Vellum objects, so it is like initial state, even it is written over here also, initial data, initial geometry. But if I use a Vellum source, this one, and I'll use swap path and constant same path, and so then it will be a stream like we are doing point, but that is so heavy also for now, and I'll show you with some example later this thing. So for now this is, I'll wrap up for now, and thanks for watching. If you have any doubt with this one, if you can't find anything, or you have any issue with this one, then just comment me, I'll tell you what is an issue. Thank you.